This is another tutorial on vector addition, only in this case we have 3 vectors and they are not at right angles to one another. This problem says, while chasing a bird, a cat runs the following path. What is the resultant displacement, including angle of the cat? It doesn't matter which order we add our vectors. So what we're going to do is find the total displacement in the horizontal or x direction, and then find the total displacement in the vertical or y direction. And through that, we're going to actually make this into a right triangle problem just as before. So we rewrite each vector one at a time. Here's our first vector, which is 20 meters. We'll write it again. And it's the same vector as long as it's the same length in the same direction. It doesn't matter where we write it, it's the same vector. And so we'll write down our 2 components. Now this one is kind of a trick question of sorts because this one only has an x component, 20 meters to the right. But I want to write down my direction as well. You'll see why later on. And there is no vertical component to this one, so of course there's no direction with it. My next vector is 10 meters and it's at a 40-degree angle. So I'm going to break this into its x and y components. Now in this case, to get the x component, I'm going to use my SOHCAHTOA, and because that is the adjacent side, and I know my hypotenuse, my SOHCAHTOA says that I'm going to use my cosine, my adjacent and my hypotenuse. So I can show my work up here. Cosine of 40 degrees is equal to my x component over the hypotenuse, which is 10 meters. So I multiply each side by 10, and I get my x components, which comes out to be 7.66 meters. So 7.66 meters to the right. To get my y component, that is my opposite side, and again I know my hypotenuse is 10, so opposite and hypotenuse, we're using the sine. So the sine of 40 degrees is my opposite side divided by my hypotenuse. Multiply each side by 10, and I get that my y component is 6.43 meters, and that is up. I have one more vector, and that is the 11 meters here. That is upward. So this is, again, just like the 20, which was horizontal, this one is entirely vertical. So in this case, though, there is no horizontal component. It is entirely a vertical component, 11 meters up. At this stage, what I can do is I can quickly see what my total x and my total y, or my total horizontal, my total vertical displacements are going to be. The arrows help me show if I should add them or subtract them. So because the 20 meters is to the right and the 7.66 meters is to the right, I would add those two. But if they were in opposite directions, left is negative, I would subtract them. So I'm going to go to a new page here, and here's my shorthand notation for total. It is a Greek letter sigma, and it means to add up or sum up all the x's. So sigma means to add them all up. So I have positive 20 meters, because that was to the right, positive 7.66 meters, because that was to the right, and my 0 meters, I'll write it down. And I get a total of 27.66 meters, positive meaning to the right. I'll do the same thing to get my total vertical displacement. The first one was 0. The second one was 6.43 meters up, so that is positive. The next one was 11 meters up, so that is also positive. and that gives me 17.43 meters up. So I have these two displacements, 27.66 meters to the right and 17.43 meters up. We want to find the total of those two displacements. So this is no different than the first tutorial, in which we have two vectors that are perpendicular to each other, and we want to find not only the displacement, the resultant we call it, the total, but also the angle as well. Now when I draw those two vectors, I want to draw them to scale as best as I can, 27.66 meters. And I draw them tip to tail. So the tip of the first vector meets up with the tail of the second vector, which isn't quite so large, 17.43 meters up. And we are finding the hypotenuse and the angle as well, the direction. To find that hypotenuse now, I'm going to use the Pythagorean theorem. So d squared is equal to 27.66 squared plus 17.43 squared. I solve for d, and I get 32.7 meters. That is the magnitude, but I need the direction as well, since it's a vector. So to get the angle, I know the opposite and the adjacent side, so that is my inverse tangent. To get the angle, we take inverse trig functions, or the arctangent, as it's sometimes called. So tangent is opposite, 17.43, divided by the adjacent, which is 27.66. And we get our angle, comes out to be 32.2 degrees. So make sure your calculator is in degree mode at this time. Again, we could keep it as this with two separate answers, or we could write it all as one. I'm going to write it all as one. So my magnitude, 32.7 meters, put a semicolon. Now I could say that it's so many degrees above the positive x-axis if I want, but I think the picture is better than describing it in words. So I'll just actually trace here, write my direction just as I see it, and I have that with respect to the horizontal, I have my angle with respect to the horizontal, 32.2 degrees.